So we start with our table, horizontal and vertical. Initial horizontal velocity is u cos theta, initial vertical is u sine theta. Acceleration horizontally is 0, vertically is minus g, and then if we use v equals u plus at, horizontal is u cos theta, vertical is u sine theta minus gt. And then if we use s equals ut plus a half a t squared, x is ut cos theta, and y is ut sine theta minus a half g t squared. Greatest height happens when the vertical velocity is 0, so that's when u sine theta minus gt is 0. So gt equals u sine theta, t equals u sine theta over g. To find h, we now need to substitute this into our y formula. U sine theta times t minus 1/2 g of t squared, so that's u squared sine squared theta all over g squared, and the g cancels with the g squared. So we have u squared sine squared theta over g minus u squared sine squared theta over 2g, which is u squared sine squared theta over 2g. So we start with h, which is u squared sine squared theta all over 2g. So that's 25 times a quarter over 20, which is 5/16. Little h will be ut sine theta minus 1/2 g t squared. And we also know that the time to get to the maximum height was u sine theta over g, so that is 1/4. If we're moving half the distance horizontally, then our t is a half of a quarter, which is 1/8. So h will be u times 1/8 sine of 30 minus 1/2 times 10 times 1/8 squared, so 1 over 64, which is 15 over 64. So h to h is 15 over 64 to 5/16. 15 and the 5 cancel to give 1 and 3. And if I multiply both sides by 64, I get 3 to 64 over 16, which is 3 to 4.